The easiest way to solve a rational equation is to get rid of the denominator. Now, one of the ways we can do this is we can multiply every single term in our equation by the lowest common denominator. If I look at 2x and 4x, the lowest common denominator is going to be 4x. So I'm going to multiply 4x by 5 over 2x. I'm going to multiply 4x by 3 over 4, and I'm going to multiply 4x by 9 over 4x. Now I can cancel things out. The 4x and the 4x are going to cancel out. The 4 and the 4 are going to cancel out. The 2x and the 4x are going to cancel out and leave me with a 2. So my new equation is 2 times 5, which is 10, x times 3, which is 3x, equals 9. Now I just need to solve for x, so I'm going to subtract 10 from both sides. I'm going to get 3x equals negative 1. Then I'm going to divide by 3, and I get x equals negative 1/3. The final thing I'm going to need to do is I'm going to need to substitute this back into my equation. So I've got 5 over 2 times negative 1/3 plus 3 over 4 equals 9, and 4 times 1/3. So when I multiply this out, I get 5 over negative 2/3 plus 3 over 4 equals 9 over negative 4/3. Now when I simplify these fractions, what I'm going to end up doing is I'm going to end up multiplying on the denominator. So I get negative 15 over 2 plus 3 over 4 equals negative 27 over 4. When I convert this to being over fourths, I get 30 over 4, or negative 30 over 4 plus 3 over 4, and it does equal negative 27 over 4. So this is my solution. It does work out properly. Here's another example. My lowest common denominator in this example is going to be x squared. So the first thing I'm going to do is I'm going to multiply everything through by x squared. And my final term is going to be 4x squared over x squared. Now I can cancel out common terms, so that's going to cancel. One of my x's here is going to cancel, and it leaves me with 3x squared plus x equals 4. Now since this is a quadratic, I'm going to have to subtract 4 to make it equal to 0. So I've got 3x squared plus 4x, or plus x minus 4 equals 0. Now I need to factor this. So I know I'm going to need to multiply to 12 and add to 1, which is going to be positive 4 and negative 3. So I've got 3x squared minus 3x plus 4x minus 4 equals 0. Factor out of 3x. I got x minus 1. Factor out of 4. I've got x minus 1. And I get 3x plus 4. And x minus 1 equals 0, which means the solution to this equation could be negative 4 over 3 or positive 1. So I need to substitute both of these back into the equation to see if it's going to work. So my first check, I've got 3 plus 1 over negative 4/3 equals 4 over negative 4/3 squared. Change this to the top, I get 3 plus negative 3 over 4 equals, now negative 4/3 is going to be 16 over 9, which is going to make this 36 over 16, because I multiplied the 9 onto the top here. So now I just need to check it. 3 plus negative 3/4 equals 36 over 16. And we know that 36 over 16 we can reduce to 9/4. So when I check this, 3 minus 3 over 4 does equal 9/4. So I did have the correct one for 3/4. So 3/4 is a solution. I've got 3 plus 1 over 1 equals 4 over 1 squared, which gives us 3 plus 1 equals 4. So 1 is also a solution. So in that equation, I have two solutions. I've got negative 4 over 3, and I've got positive 1. In my final solution, I want to multiply by my lowest common denominator, which is going to be x plus 4 and x minus 2. So when I multiply that by the top, I've got 5, x plus 4, x minus 2, all over x plus 4. On this side, I've got 3, x plus 4, x minus 2, all over x minus 2. These are going to cancel, and these are going to cancel. So I've got 5, if I multiply this in, 5x minus 10 equals 3x plus 12. Now I'm just solving for x. This is a fairly simple algebraic expression. I'm going to get 2x minus 10 equals 12. Add 10 to both sides. I get 2x equals 22, which means x equals 11. Now I need to check it back in this equation. So I've got 5 over 11 plus 4 equals 3 over 11 minus 2. So this one's going to be 5 over 15 equals 3 over 9. And of course we know it does, so 11 is the solution to this equation.